Hi guys, today we're looking at lesson 11.3 and we're on task 2. So we're still rewriting exponential models. Alright, so it says to analyze an exponential model. You can rewrite an exponential growth model to reveal information about the rate of growth for a particular time interval. The value of a collectible is $25 and its value increases by 8% per year after it is sold. Show the model where t is measured in years. F of t equals 25 times 1.08 t. All right, so remember our equation is f of x equals a times 1 plus, if it's growth, it says it's increasing, so it's 1 plus your interest rate to the x power, or in this case, they're using t for time. All right, so it says show the model where t is measured in years. All right, so they use your A as your initial value. Okay, that comes from your given number here. And it says it's increased by 8%. So remember, 8% is equal to 0.08 as a decimal. And we have 1 plus your interest rate. So 1 plus 0.08 is the 1.08. So it says show the model where t is measured in decades. Okay, decades, remember, decade is 10 years. So g of t equals 25 times 1.08 raised to the 10 times t power. Okay, so 10 is for the decade and t is for years, measured in years. So that equals 25 times 1.08 raised to the 10th power raised to the t power. And they're just using properties of exponents to rewrite that so that they can do 1.08 raised to the 10th power, which gives you 2.16. And if you want to check that out, you can use your calculator to do, and I've already got this typed in here, 1.08 raised to the 10th power is 2.16 approximately, okay? All right, so once you have that, you know that this number is your 1 plus your interest rate. So it says, what is the decadal growth rate expressed as a percent? All right, so as a percent. So we know that it starts with 1 plus your interest rate, so 1 plus r equals 2.16, and so we have to subtract 1 from that. So it's 1.16 when we subtract 1, and this is written as a decimal, and it says what is this as a percent? So that would be 116%. So this would be 116%. So in the course of 10 years or over a decade, the value of that collectible will go up 116%. So that's pretty good. All right, let's see what else it asks us. Show the model where t is measured in months. Okay, again, we're going backwards now. In months means we take our initial interest rate and divide it by 12. So that's what they're showing here. T divided by 12, so our time is in years, t is in years, divide that by 12 months in a year, and that gives us the 1.006 to the t power. So now it says, what is the monthly growth rate expressed as a percent? So now we have to look at this going in the other direction. So we're going to say 1.00, well, I can't write here, 1.006, and that equals our 1 plus our interest rate, right? All right, so if we subtract the 1, then that gives us our R. So our R is going to be 0.006, and now we want to write this as a percent again, so we're going to move it 2 decimal places. So that means it's going to be 0.6%. So this should be 0.6%. All right, that's all for task 2. If you have any questions, please let me know. Lesson 11.3, Task 3. Analyze exponential models. Recall that half-life is the length of time required for half of a sample of radioactive material to decay. You can write an exponential decay function in half-life form if it is not given in this form. Alright, so it says a scientist has a sample of radioactive material for which the rate of decay is known. What is the half-life form of the exponential decay function for this material? What is the material's half-life? So the initial amount is 300 milligrams, and it's going to decay at a rate of 87.5% per month. Okay, so this time we're doing per month instead of year. All right, so it says the rate of decay is 87.5% per month. So the monthly decay factor is 1 minus, and they're changing the percent to a decimal again, so 1 minus 0.875, and that gives us the 0.125. All right, so it says a model for the situation is A of t equals 300, that's our initial amount, times 0.125, that's our decay rate, raised to the t power, which is in months again. All right, so it says rewrite the exponential decay function with a base of 1/2. All right, so if you look at this 0.125, okay, can we rewrite that? So if I say 0.125, so 0.125, that's a decimal form, but I want to know, is there a fraction form of that? So I hit fraction, and it's going to tell me that 0.125 is the same as 1/8. Okay, so they're going to rewrite the 0.125 as base 1/8. And the reason they want to do that is because we're looking for a half-life. So that means our base has to be 1/2. Okay, so 1/8 is not 1/2, but can we rewrite it in that form? So let's look at 1/8. So remember properties of exponents. So 1/8, think about exponents. You can remember that 2 times 2 times 2 equals 8. Okay, so that's 2 to the third power. All right, so we're going to rewrite 1/8 as 1/2 to the third power. So if you do 1/2 raised to the third power, all we're doing is rewriting 1/8 in this form. So 1 to any power is just 1, and 2 to the third power is 8. So this is just an equivalent expression using properties of exponents to rewrite that. Okay, so we're going 300 times 1/2 to the third power, that's the same as 1/8, and we still have it raised to the t power, which is expressed in months. All right, and again, we're doing that because we're looking at a half-life, so our base needs to be 1/2. So we have 300 times 1/2, so 300 is our initial value, times 1/2, that's our half-life, raised to the 3t power. So it says the half-life form of the exponential decay function is A of t equals 300 times 1/2 to the 3t power. The material's half-life is 1/3 months because 1/3 of 3 equals 1. Okay, so when you substitute 1/3 in as t, you're going to get 150. 150 is half of 300. And when you're talking about a half-life, that's what you want to know. How long does it take to decay by half? Okay, so it says y has 0.125 been replaced with 1/8. Okay, so this is a decimal, and it's just replaced with an equivalent fraction. All right, so it says to write the exponential decay function in half-life form, the base needs to be expressed as a fraction. All right, y was 1/8 replaced as 1/2 to the third power. Again, we're talking about half-life, so it needed to be a base of 1/2. All right, so it says in the half-life form of an exponential decay function, the base must be 1/2. All right, so it says which property of exponents justifies rewriting 1/2 to the third to the t power as 1/2 to the 3t power. Okay, so this is two exponents being multiplied, and it's just rewritten here, and that is a power of a power. All right, that's all for task 3. If you have any questions, please let me know.